Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard at Richard on the MakeCode Forum.
And I'm Joey at J1 on the MakeCode Forum.
And today we're working on something special. Well, today, for people who don't know, it's October 1st. October is the best month of the year. This is not debatable. Everyone agrees about it. But it's especially special this year because we are going to be having our fall game jam starting today. So I haven't put up the site for it yet. It's going to go up later today. But I have one last thing I have to do before I put the site up, which is if you've ever seen one of our game jam pages while the game jam is going on, we always have the same format. We have this like banner image, we got a description, and then we have 3 GIFs of games that are like related to the theme. All right. Now, these are always fake games for the most part. I think once or twice there's been a real game in there, but for the most part, they are fake games that we made purely to make GIFs that like adhere to the theme. Mm-hmm. All right. So I've already made 2 of these GIFs. Normally I get other people to make them too, but I forgot to ask people in time. So I'm just making it this time. Actually, one of them was made by Shannon. I need to make one more. And so that is what we're going to be working on today. And I'll also be announcing in the stream what the theme of the game jam is. So if you are tuning in, you get a brief preview. We're going to announce at the end of this stream what the theme is. And until then, you can look at the game I'm making and see if you can guess what it is based off of this. Mm-hmm. So I already started making this. But Joey, seeing what it is right now, do you have a guess as to what we're doing here?
I'm guessing that you're carving a key.
Yes, that's correct. So Joey, how much do you know about locks?
I've played Oblivion.
That gives me no information.
Okay, I know how locks work. If that's the general question.
Okay.
Right, like you're pushing things up, and so that they all line up, and then you can just open them.
Yeah. So there are a bunch of different ways locks can work, but we're right now talking about the classic one that you see most often on doors and with padlocks, where you have a key that looks kind of like this thing over here, where it's got like a bunch of ridges cut into it. And on the inside of the lock, it looks something like this. Okay, so this is commonly referred to as the key core, and it has a few parts. So we have the key cylinder, which is right here where you're putting the key inside. And then it has all of these pins inside. And the goal of the lock is to rotate the cylinder. So, you put your key in, it either turns or it doesn't. So you have to be like, okay, how does my lock know that I have the right key? This is something that as a child, I always, perplexed me. And it was only upon, becoming an adult that I realized that it's actually much simpler than I expected. So the way it works is we have this cylinder. So that's what this thing is right here. This is the part that turns. And we have these pins. And then we have these other pins up here. So everywhere you see this black line, this is a separation between the bottom pin and an upper pin. And then up here, we have springs. So the springs are constantly pushing both of the pins downwards. And all of these upper pins are usually the same size. They're not in this drawing for whatever reason. But the lower pins will be of different sizes. So this, hi Lucas, and hi random user, this determines the key for your lock. So typically, when you have your key, what you're doing is your key is moving each of the pins to a different height from the bottom. And when all of the pins are at the correct height, this little break point between the bottom part of the pin and the upper part of the pin gets aligned with the part of the cylinder that rotates. So normally, if it is not aligned correctly, either the bottom pin or the top pin will be blocking it from rotating because it is in between the cylinder and the thing that the cylinder is rotating inside. So it cannot move without breaking one of those, which you can't do. But if you have all of the pins at the correct height, then everything will be lined up and the cylinder can turn. Okay, that makes sense? Mm-hmm. So the way that cylinders or the way that locks are keyed is by just, they have all these chambers with all these springs, and then they just take a bunch of different pins of different heights and they put them in here. And normally there are a set number of heights. There'll be like 8 different heights that you can go through. So the process of picking a lock, typically what you are doing is you are trying to figure out the height of each of the pins so that you can either push them into shape and get them stuck in the right position, or you want to create your own blank key that is carved correctly so that you can insert it and, do it. And there are some older school ways of creating, of breaking into locks that, kind of have to do with other things. But we're not going to get into those, We're not master lock pickers. And by the way, this is the most simple version of a lock. A lot of locks are actually more complicated than this. But that's the one we're dealing with today. So I started making this game where we have a bunch of pins. These are supposed to be the springs, and then these are the upper part. And we have the cylinder, and then we have a key, and this key should unlock this lock. All right, so it's made, I have it generated so that it matches wherever the pin sizes are. So if we keep, doing this, we'll keep doing random things and random keys that will unlock the lock. So what we're going to do is we want to make it so that as this key animates to the left, we want it to push all of these pins up and down until it gets to the final position. And then all of the pins should be lined up correctly. And this might involve us having to regenerate our lock a different way. But, we'll worry about that later. Sorry, regenerate our key a different way. But we'll worry about that later. Right now, I have a thing that's kind of working, and we'll see if it works when it actually goes into the cylinder. So, by the way, this is going to be a JavaScript stream. So I'm pretty excited about that. Random user says, gasp, I know the theme of the game jam is crime. It's a good guess.
We'll see how close you are.
Yeah, I'm going to tell you, that is not the theme, but you're pretty close. Okay. So we've got a sprite, which is this key, and we want to have it be moving to the left. So let's go ahead and just grab our key and say test key dot vx equals -2. So it's just going to be inching along there. All right. And as it moves to the left, I want to adjust this, the pin heights, so that they line up with the actual thing. Also, we should make it so that the z of our key is higher than the z of our lock, which is 10. So test key.z equals 11. There we go. Okay, so now our key is actually visible. So we want to make these pins move up depending on how high the thing is underneath the actual pin. And to do that, inside of our little lock class, which I created here, there is an offsets array. And if we put numbers in this offset array, it will actually align them to based off of these offsets. So if we go into here, and instead of saying this dot offsets push 0, we say this dot offsets equals this dot get key. This will actually get us our solution. So you can see this is what they should look like to solve it. And everything is lined up, right? So all of them are lined with the top of the cylinder, and all of these ones are on top of the cylinder. And there you go. So we want to make it so that when our key goes in, we make this shape eventually. All right. So I've written a function that is called get offset or something like that. Let me look for it. Yeah, here we go. Find offset. And this takes in an image, which is going to be our key image. It takes in a left and a width. And what it does is it just scans down in that image to find the highest up pixel within that rectangle that is set. So the idea being that, if we have an image, say we have this key right here, if we were to do the scan at this X value for this width, the value we would get back would be this pixel up here, because this is the highest pixel in the key. And we're going to be using that to set the offsets of our key. So we have this update offsets function. We have this total pins width, blah, 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 blah. And we have an image. We have a Y offset in that image and an X offset in that image. And we're going to go ahead and try and find out for each of our pins, what is the offset. So we're going to start with looping over all of our pins. So we're going to do for let I equal 0, I is less than this dot pins dot length I plus plus. And for these pins, we're going to go ahead and say const offset equals find offset. And now to get our offset in the image, we want to basically convert the X space of our pin to the X space of the image. So we need to figure out what our X value is. And our X value for this is going to be equal to I times spring width plus spacing. And that should tell us where the left of our pin is. So with this, we also have an X offset of our key. So that is going to be the amount that our key has been pushed over into our lock. So in other words, the offset for each of our pins is going to be equal to the X value from the left of our lock minus the left value of our sprite, which is going to be our X offset. So we're going to do find offset. We're going to do X minus this X offset. And the width is going to be equal to our pin width, which is the spring width. I know I'm actually going to go ahead and rename this right now. We'll rename this to pin width because that's easier to understand. There you go. Okay. And then we need the image, which is going to be our image. Okay. So this is going to give us a number. Let's go ahead and do Hyberlangus. Lucas says, my dad had a cray lock picking phase. Yeah, it's a hobby a lot of people like to do. Let's see. I want to do console.log I equals, and then I want to put in this offset. And we're just going to call this every frame, basically. So we'll do this inside of our create renderable. And we're going to do test block.update offsets. And the image is going to be our test key.image. Our Y offset, we're just going to put that at 0. And because we're not using it yet. And our X offset is going to be equal to, we need to know what the right of our lock is. So the right of our lock is equal to this total width, which is all of this. Did I make it Y offset, then X offset? God, I'm a crazy person. Okay. That's plus 20 minus test key dot left. This will be test key dot pins dot length. And this is probably protected. Is it any good lock should have this being protected? Oh no, it's not. Oh, this is test key. It should be test lock. Okay, so now we should have a bunch of things getting printed out. We have I equals 8. We should, as this moves in, start seeing some of them not be 8. Nope. Doesn't look like we're doing it. All right, we'll try again, I guess. Let's go to our console and make sure that we're at, let's log all of our values so that we know like what is our thing here. We're going to log our X offset. and see what we're getting passed in there. Okay, so stop right here. Our X offset is equal to 3. That should mean we are 3 pixels in. And 1, 2, 3. That looks right. Yeah, we're 3 pixels in. Okay, so it looks like we're at least getting that correct. And if we just let that keep going for a bit, it should go up as we go to the left. Yeah, there we go. So now it's up to 10, 11, 12, 13, 14. Good. All right. So we know that that is being calculated correctly. That's good. So in here, we're going to try and figure out what our X is. So right now we're doing this X minus the X offset. So if we were at right here, so our X would be like 3, and we were to subtract this X offset over here, that would give us zeros. Okay, so this is very wrong. What we should be doing is to find our offset in the image, we need to do, let's see, the total width minus the X offset. Wait a second. I need to, this is one of those things where when I'm on stream, I can't wrap my head around it. Let's draw a diagram. All right. So this is our cylinder. This is our key. That makes this part our X offset right here. Now here's the pin we're trying to find the thing for. So this right here is the X value for our pin. So in order to find out the offset of this guy inside of here, we need to take, let's see, we can find the left of this guy is equal to this value. And we need to say the left of this guy is equal to the total height minus the X. So it should be the total height minus the X, and then we subtract this left from that left. Right, and that's just to give us a negative number. Okay, that's right. Right, so instead of doing X minus X offset, we're going to be doing X minus X, total pins width minus X offset. All right. And now as these go in, we should see it change. Unless my find offset function doesn't work. Gotta love debugging stuff. All right. Let's go to the find offset function. So we're doing for let x equals 0, x is less than width, x plus plus, and we're just doing image.getPixel x. Okay, so this should be left plus x. Okay, there we go. We can see the first pin changing. Now this first pin and second pin are changing. Now the first, we got the, sorry, these are the last pins actually. We have the last 3 pins changing. And there we go. Okay, so this seems like it's working. So it might not be the right values, but we should at least be able to see the pins move now. So we're going to go to our update offsets. And we're going to go ahead and say this dot offsets of I equals offset. And, ooh, okay, wait. Oh, I see. Right. We get the maximum value when it's oh wait, we should be doing the inverse of this. Right? You can see right now that when there is a when there's nothing like down here, we get the maximum value, right? And so that's why it's getting pushed all the way up. But here, as we get to these bumps, it's going down instead of going up like it should be.
Gotcha.
So what we need to do is we need to do equals image dot height minus offset, like that. There we go. Now it's getting pushed up too far, but it does seem like it's actually tracking the thing now. The reason it's getting pushed up too far is because there's some blank space in our thing above where the key is actually being drawn. So there's like a set like XY value that we should be, there's like a set X value that we should be, or I'm sorry, Y value that we should be subtracting from our thing here. Okay. So that looks good. I'm just going to try and eyeball the value. We're going to do -5. Oh, whoops, that doesn't work. We're going to make our offset equal to offset -5. No, okay, wait, I'm making everything worse. All right, so we want our offsets to be image.height minus offset right here. I guess what we want to do is say if offset equals image.height, then this dot offsets of I equals 0. Else, we do this difference and then we subtract like 5 from it. All right, give that a shot. Okay. Need to subtract a little bit more, but we're getting there. So let's subtract 7. I think 2 pixels more might do it. At a certain point, I'm just going to have to make this a key that I control with the things, because waiting for this thing to go is excruciating right now.
Fair enough.
All right. Well, this is kind of right. Okay, let's make it so I can flicky, because right now this is annoying. So we're gonna do get rid of that VX, and we're gonna do controller dot move sprite test key VX of 10, VY of 0. Okay. So now I can just go ahead and move this right on over, right into position. All right, this was what I was worried about. So it seems like the issue here is because we're drawing these diagonal lines, we're not actually generating the key in a very good way, you know? Like, we can't guarantee that it can actually fit in this next divot because we have it going up or down once it reaches the X value. So, like, I don't know how keys are actually cut. Let's look at a key. Schlage key. I feel like for most of my life, I have had Schlage keys.
Schlage.
Okay. Yeah. All right. So this is what I'm used to seeing. So it looks like they do like bottom out. Right?
Yeah.
So I'm guessing there's more spacing between the pins, and also the pins are probably triangular shaped. which the pins that we have are also kind of triangular shaped a little bit, you know, like they come in a little bit. But it might make sense for us to generate this key in a different way.
Mhm.
So let's try that. We have our key. This is our key handle, by the way. And this is our key drawing code. So we're going to try to draw the key a little differently. So I'm going to go ahead and rename this as draw key 1 or 1. Yeah. And we're going to go ahead and make a new draw key function where we try to do something different. So what we're going to try and do this time is we're just going to draw a rectangle, and then we're going to carve out the keys, as opposed to calculating what the height should be at each point and then drawing a line, which is what we're doing right now. So we're going to go ahead and get rid of all of this business. Except we are going to take this part right here. This is drawing the I don't know what this height is referencing, so we'll just get rid of it. Okay, so we're just going to go ahead and see what this generates right now. Okay, so right now we have just the handle. So we need to generate a rectangle, basically, that's going to come off from the rest of this. That looks like a key that we can then carve away. So we're going to do out.fillRect, and this is going to be equal to, the x is going to be 0, the y is going to be top, the width is going to be blank width, and the height is going to be whatever the height should be, which I think is like the max pin height plus 3 or something like that. And then the color we're just going to do yellow, so that's 5. So okay, there we go. All right, we're a little bit off, so we want to push this down 3 pixels or so. Let's take our top and make it 6. There we go. Okay, we got a little blank going here. Let's actually take it down 1 more pixel. That's cool. And we want to now carve our pins into this, basically. So we're going to be just drawing the same pin shape, but into our thing. So let's actually just call the draw pin function for now. So we're going to do hi, Robbie, for let I equal 0. I is less than offsets dot length I plus plus. Our x is equal to I times our pin width plus spacing. And then we're going to call draw pin. And I think draw pin right now does not take in a whoops. Draw pin right now takes in just an x, a y, and a height. We're going to make it also take in a color and a target. Maybe an image. So go ahead and make this be target. Make this be color. We're going to go up to where we call draw pin. Not that one, the other one right here. And we're going to go pass in our pin color and then the screen for our target. All right. So now we're going to go ahead and draw a pin. We're going to draw it at our x. We're going to let's set the y to be equal to our top plus offsets of I. We're going to set the height to be equal to, I think it'll be, you know what, it'll just be top actually. And then our height is going to be equal to offsets of I. And then for the color, we want it to be transparent. So we're going to do 0. And then the target is going to be our out image. All right, let's see what this does. Nothing apparently. Okay. Let's go to our draw pin function to make sure I didn't mess anything up. All right, so we have the target. We're doing target.fillRect at x, y, pin width, height, color. That all seems right. And then x plus 1, this is drawing the little under divot part. So when we call draw pin up here, we should be passing an x, y, height, color. X, Y, height, color 0. Let's set 0. Let's change it to red. Okay, all right. We're doing this after we, all right, before we fill out the links. We're just overriding what we're doing. There we go. Okay. So this looks like our pins are indeed in the right position. Right? That looks good. But I think we are doing the inverse yet again. So we need to, right now, right? So this one right here is supposed to be the pin for this one. And if we carve this all the way down, this pin's not going to move at all when actually it needs to move the farthest. So what we should actually be doing here is for our offset here, we should be doing max pin height minus offsets of I. Okay. That looks like we're going negative for some of these. Oh, right, because these can be up to... Okay, wait. This should be like max pin height plus 3 or something like that. There we go. Yeah. So the reason it's plus 3 is because we have an extra 3 pixels in the cylinder. That's, like above the max pin height. Okay, so if we change that back to transparency, so change this to 0 for our color. Then there we go. We got some weird looking keys. So the reason this is so weird looking is because we have all of these upper lines, right? The ones that go all the way up to the top in between each of the pins. We want to smooth these out, I think. So, I guess what we want to do is then do out.fillRect of the x is going to be x plus pin width. And the y is going to be equal to top. The width is going to be 1. And the height is going to be equal to... We basically want to figure out what the minimum is between the two. So whichever one has the lower value, that's what we want to carve it down to. Mm-hmm. So we can do math.min of, and then grab this and offsets of I plus 1. And then we want to make the color transparency. And we only want to do this if I is less than offsets.length minus 1. That in there. All right, let's see what that does. Okay, so now we're indeed chopping out the thing a little bit. What if we did 1 plus this? I guess that looks worse, doesn't it? -1 plus? Yeah, I think that is slightly better, but so the one thing we could do to make this key look nice is to, when we are generating the locks, like make a maximum difference between the two pins. Then it will end up generating nicer looking things as opposed to just being super random like it is right now, you know?
Mhm.
All right. Okay, so this works. Let's go ahead and move this over now. And it's still probably not going to be perfect, but it'll be much closer. So there we go. Okay. I think we have like an off by 1 error or something because it seems like these guys are getting stuck on the next one. But because this one should definitely be going down, but I can't get it to, oh no, there it is. Okay, we have an off by like 2 error, I guess. Because now everything is in the correct position. They're just off by 2. So
Gotcha. Yeah.
let's go to that update offsets function right here. And we're going to say our x equals this, this, and then we want to do +2 or -2. I'm not sure which, but we'll see. I think +2 was correct. Yeah, there we go. So there we go. Everything is lined up correctly now. Right? It would be best if these like totally matched up, but well, let's make that happen, I guess. So if you want these to totally match up, then we need to have the offsets count for 1 less. So we'll make this be -8. And now hopefully everything just fits all nice and perfect. There we go. So everything is fitting in perfectly. I guess it's now 1 pixel not lined up with the cylinder anymore. Well, I think we need to move the key up 1 pixel anyway. We also need to outline this key. So what am I looking for? Right. So where we keep the key. So we want to make this be 70 or 66. So we're up 1 pixel. Nice. And now everything's going to be off by 1 again. There we go. They don't look like they're off by 1, but they are off by 1 because they're going underneath the key. So that's perfectly fine because we can just go into here and change this back to -7. There we go. All right. Good. Everything is lining up in the key, in the lock. That looks good. All right. Last thing I want to do is I want to outline this. So we're doing like yellow with orange outline. So I want to outline this key. Belenga says, I want a lockpick. It's pretty fun. Just don't do it for any illegal purposes. Great. Okay. So we want to outline this guy. We're going to go ahead and just do this as an extra step, I guess, and do for let x equal 0, x is less than out.width, x plus plus. For let y equal 0, y is less than out.height, y++. We're going to say if out.getPixel xy equals 5, which is yellow. Then we're going to look at all the surrounding pixels and see if one of them is transparent. So we're going to say if out.getPixel x y equals 0. And we are going to take this, put it right here, put in an OR, and then do all 4 of the immediate ones. So we're going to do x plus 1, x minus 1, y plus 1, y minus 1. If any of these are the case, then we're going to do out.setPixel x, y, 4, which is orange. Okay, what did I do wrong? Statement. You got this if statement. You got these parentheses. Oh, I have an OR at the end here. Too many ORs. All right, so there we go. We have outlined our key. Still looks a little too spiky for me, you know?
It kind of looks like a sword that's been used too much to hack at metal or something.
So theoretically, if we carve more away from this key, like we shouldn't cause any problems as long as we're not carving deeper. So let's go to where we're doing our extra little thing right here, and we're going to change its width to be 2 instead of 1, which should smooth it out a bit more. And let's get rid of that -1. We'll just leave it as 0. So go. Okay. Well, still doesn't really look like a key. I think, honestly, to make it look like a key, we would have to put more space in between our pins, which I don't want to do, you know?
Yeah. Make it hard to fit on this size. Ooh.
Yeah. Okay, we should probably make our outline a different color than the pins. So we'll change the pin color. Our pin color is going to be what? Like teal? Teal is
Teal's good.
6. There we go. All right. Cool. Okay. All right. Well, this is the main thing that I wanted done for the GIF, was just having an animation where this key goes over and, you know, puts all the pins into place.
Mm-hmm. We probably don't want to do the finishing touches that we talked about yesterday, because that would give it too clear of a clue. Maybe it would actually be more confusing.
Probably. But so we want to make this into something that looks like a game. All right.
Mm-hmm.
So I think what we're going to be doing here is.
Can I make a suggestion for the game?
Sure.
We have the keys flying by like a marquee. There's like 6 of them, 5 of them randomly generated, and 1's the correct one. And you have to watch as it goes by and just like figure out which one's which from looking at it.
Oh, okay. So you have like multiple keys, and you have to be looking at the thing.
Yeah.
Figure out which one is the right one for the lock.
Yeah.
Interesting.
It'd probably be infuriating, but I mainly just like it because then we have a bunch of different keys on the screen, ones that are randomly made. But you have to carve the key. That might be mean, but I like it.
I like carved key. That's an interesting idea. You know what? We could make it so that you start with a blank key. You have to carve it down. And then when you press A, it just really quickly puts the key in place and then has like a nope. And then it pops back out. And then you can adjust it some more and press A and it like goes in and then comes back. You know, we just do like a real quick animation.
I like it. Okay.
So let's actually try that. We're going to go ahead and go to our, let's do the animation part. So we're going to get rid of this move sprite. And we're going to do controller.add whoops. Random user says it's reminding me of that table sawing game. What, Stable Table? I don't know if we're getting to quite the heights of Stable Table. You know, that was a once in a lifetime game. Like, when I made Stable Table, I knew I wasn't going to do anything better than this for the rest of my life. I knew that was me peaking. So, and also Shannon and Vivian were there. All right. So we're going to go and make a Boolean. This is going to be is animating. And we're going to set it to false. And then inside of here, we're going to say if is animating, then return. Else, we're going to say is animating equals true. And we're going to do control.run in parallel. And here's where we're going to do our animation. So we want to make this guy move over to the right position. So we're going to do animation.run movement animation. And first, I just want to figure out what the correct value is for this. So we're going to put in a thing. We're going to set it to h negative 40. I don't know. And we'll see where we get. And then we're going to do for pause for whatever the duration is. So duration will be 500. Pause for 500. And then set is animating to false. Okay. There you go. I'm going to press A and see where we get. Nope. Need to go a bit farther than that. So let's say 50. Nope. All right. 60. Okay. Looks like we overshot it by maybe just 1 pixel. So let's do negative 59. This looks correct, but I'm guessing because we're off by some small value, it's why it's not drawing correctly. You know?
Yeah, I don't. It doesn't look correct.
It's lined up correctly, but these guys are not being drawn correctly. Mm-hmm. Some of them are, but some of them are like got this like little off by 1 error. We bring back the move sprite, do it again. And now if I move, yeah. So if I moved less than a pixel to the right, I just tapped it. And that got me to where it was lined up correctly. So let's go ahead and run this, and then we're going to do animation.stop animation, animation.animation type dot movement animation on our key. And then we're going to do test key dot left equals. So the left was 80, and then we are subtracting 59. So it should be equal to 21. All right, so this is where it's not quite correct. So if we make it 21.5, there we go. That works correctly. All right, I'm not going to pretend to know why this is the correct one, but it works for me. All right. So that's great. We want to now make it animate back, and we also want to make this animation nice. So we're going to go ahead and switch from using an H. We're going to use a Q. And we're going to do, Woof Woof says, oh, I see the wire on the headphones now. Yeah. Woof Woof was trying to say that yesterday the reason I was doing on the rhythm game was probably because I was using Bluetooth headphones. And I was like, no, you were giving me too much credit. These are wired headphones, in fact.
These ones are Bluetooth headphones, but I'm just too lazy to connect via Bluetooth because Bluetooth kind of just always sucks.
All right, so we're gonna make this be like negative. What was our value again? It was negative 59. So negative 20, and then 0 and negative 59, 0. Okay, this is more just weird than it is anything else. So we're not going to do this. We're going to go ahead and just do our own animation. And for that, we're going to go to the wonderful easings.net. I do not make this website, but I love the person who does because it has all of these nice easing functions right here. And I'm going to go ahead and copy this one, ease in out cubic. Paste it right here. And we're going to go ahead and make a function, which is going to be called animate movement. And we're going to take in a sprite. We're going to take a dx. And we're going to do let start time equal 0. And we're going to also take in a duration. So start time equals 0. Let start x equal sprite.left. And then we're going to say game.onUpdate not start time equals 0. We want to do start time equals game.runtime, right? Const elapsed, or we can do progress equals game.runtime minus start time divided by duration. And then we're going to say sprite.left is equal to start x plus dx times progress. And we also want to clamp our progress to be between 0 and 1. So we're going to go ahead and do math.constrain the value between 0 and 1. And there we go. And then we want to pause for duration. Or actually, let's just make a let done equal false. And then in here, we're going to say if progress equals 1, then done equals true. And then we're going to go ahead and say pause until done. All right. So the way I've written this will work, but it's bad. It's bad because I'm using game.onUpdate in here, which is going to register a bunch of game.onUpdates that I never clean up and only need to be used temporarily. So there is actually a way around this. I'm going to go ahead and say let callback equal colon scene dot or rather control dot frame callback, and then we're going to inside here say callback equals game.event context dot register frame handler. And then the first argument for this is the order, and we're going to do scene.update priority. And then inside here, we're going to go ahead and do game.event context.unregister frame handler and pass some callback. Now, you can get some weird compiler stuff if you don't declare the callback above where you assign it. So just do that. It'll work correctly every time if you do this. If you don't do this, sometimes it'll mess up. And then do pause until done, and we're good. All right, so now we have this nice little animate movement. And we're going to go to our thing we're running the animation right here. We're going to do animate movement, and this is going to be our test key. We want a dx of -59, and we want a duration of 500 milliseconds. And we'll pause for the, we don't need to pause. We don't need to stop animation anymore. And we do this left equals that. Then we're going to do pause for 1000. And then we're going to animate back in the other direction. All right. There you go. Exciting. Now, why did I do all this to get basically what we had before? It's because I want to use this ease in out cubic thing. So we're going to go ahead and take our animate movement thing, and we're going to apply this easing function for it. So these easing functions that you get from this website, they all take a value between 0 and 1. And they basically return a different value between 0 and 1 that is from a different function. But taking that function and putting in 0 will always get you 0 out, and putting in 1 will always get you 1 out. So it's just like how you get there is different. And you can see what it looks like right here. So it goes like, oh, like that. We have more questions, more guesses on the theme. Dungeon Jam or something. Nope. Treasure Jam. Nope.
Dungeon Jam again. Is it right this time?
Nope.
No.
So we can apply this easing function by going to our animate right here. And when we calculate this progress, let's just do let, we can say progress equals ease in out cubic of progress. And this will apply our function. So now you can see it kind of like starts out slow, gets fast, and then goes slow again, which is more pleasant to the eye. And we're going to make this go a bit faster. So right now we have this at like 500. Okay, stealth is a question. Yeah, you guys are tiptoeing around it. All right, so now a bit faster. There we go. This looks good. Copy Sprite says Heist Jam, maybe. Well, we're out the end of the stream, so I'm going to go ahead and say, Joey, can you give Copy Sprite a gold star when you get a chance?
I will spin up the bot right now.
Yep, it is Heist Jam. So the theme for this game jam is going to be Heist Jam. The idea is we are making games about thievery, rogues, and crime. So your game doesn't necessarily have to be about stealing something. You can be creative about it. You can make a dating game where you're stealing hearts. You can make a political game where you're stealing minds. You could make all sorts of different things. Or you could have a game that is just the plot is set in motion by something having been stolen in the past. Like maybe you're doing like a typical platformer and you're trying to steal back an amulet that was taken from your kingdom. So you can just kind of do your own thing. So I think it is, even though it might seem specific, you can do a lot of stuff with this theme to make it, kind of fit. Just make sure that whatever it is that you're doing, if it's something that you don't think we'll immediately get, when you submit the game, put it in the description and, that'll make it clear. So the website for this game jam is going to be going up today. So I have it all prepared. I just need this GIF that we're making. And the game jam is going to run starting today until November 15th. So November 15th, which is a Saturday, is going to be the last day. You'll have until midnight on that day to submit. And just like always with our game jams, we will be picking winners for this one. They will all be featured on the home screen until the next one. And yeah, so that's the idea. I like that Joey's Twitch bot says that the stars do not shine upon thee when you try to give someone a star.
Yeah. All
right. So that's the theme. And we hope that you all can make games for it. I think it's going to be a lot of fun. And seriously, if you're like, I was going to make a game for the game jam, I just couldn't make something that goes with the theme. Don't worry about it. As long as you can come up with some convoluted thing to make it match the theme, you might not make it into the top 3 if it's not very heisty, but we still will be judging those games and you still have a chance to get on the home screen. So
yeah, if you think I could bully the point across like on stream like I normally do, you can probably yeah. I can hack a relationship for pretty much any game. So I believe in you.
Yeah. So don't stress. Just go ahead and make your game, and we'll have a fun time playing them at the end of the jam. Now, normally is when we would sign off, but fun fact, my stream computer, the one that I use to start and stop the stream, started doing a force update, Joey, in the last 5 minutes. So we're going to have to wait for my Mac to finish update. Until then, we're stuck streaming.
Oh, that's fun.
Yeah.
Does anybody have any games?
Yeah, if you have any games you want us to play, please, give them to us. But this is a very unlikely situation that has never happened up to this point. But I guess we could do more for this. So we could do the actual carving part of this. Copy Sprite, is this the same game that we played last time?
No. Okay. New game.
All right, new game. Battle Zenith V1.68.
That's a lot of versions. Oh.
All right, I think we got to go Danger Tate. And I think this is choosing another one. We'll do Alpha. Final Forest. Okay, so this is a multiplayer game. So we should be doing. Joe, you ready?
Was that screen bigger than 160 by 120? 1 sec.
It does look bigger than 160 by 120, doesn't it?
So it just won't work.
Yeah, it won't work. Oh well. Well, we could play it against each other locally.
Yeah, I mean, you could play it against yourself locally.
Yeah, Joey's not here with me. All right, so we're still going to give it a shot, but it'll just be me trying out both parts. All right, so it looks like we have different attacks for everybody, which is cool. So Lucas has this orange ball he can shoot, and also this black attack. And Taser has this blue thing they can throw, and this other blue thing you could throw. So we got this like bubbly thing and this like whirlpool-y looking thing. And it looks like that purple bar we have is like stamina. Oh, it looks like we might also automatically heal over time a certain amount. Yeah, this is a fun idea. I gotta say, I would really love this if you could put down traps and stuff. I feel like that would be really cool. Like, so the idea is if you had like a few different people playing, you could try to like force the battle to go into a different direction. And I think the only thing that's tough is that because everyone is sharing the same screen, you need some way to hide when someone puts down a trap. So you could just make it be like a secret thing, right? Where if they push the button, it puts down a trap. But, you know. All right, my computer has restarted, so I'm going to attempt to end the stream now. Thank you for joining us. And keep an eye out for that Game Jam thing. Like I said, unless something goes wrong, it's going to be going up today. And if it doesn't, it'll be up by the end of the week, I promise. But you guys can all just be happy that you know the theme before anybody else. All right. See you later, everybody.